Oh, example 7 had more. Okay. But we already said some of this stuff. So this is kind of cool that we can write it, but we can write it down formally. It says when the graph of the function is rising, we say that the function is increasing, and when the graph is falling, we say the graph decreases. It's customary to read a graph in the same way you read a book from left to right. Okay. So starting at the left, on the graph of y equals f of x, state the intervals in which the graph rises. Okay, I think I could type this. What do you know about the slope of the curve on these intervals? Okay, so it is saying interval notation, but we'll just type it out with inequalities. Okay, when was it rising? That was with the red ones that we talked about a minute ago. All right, so it looks like from negative infinity to -1, or less than -1, and then greater than 4 were the moments where this was rising. Okay, so let's say that. So starting from the left, state the intervals with the graph rises. Okay, all right, the graph of f of x rises from, and I'm going to do this, negative infinity. I'm going to have to draw that. Negative, pen's upside down. From negative infinity, I don't have a good equation editor there. From negative infinity to, it looked like it was about -1, right? It's close to -1, all right? So we'll say it is. So from negative infinity to -1, and also from 4 to infinity. All right. So we could say that way, or we could say it. We could say when I don't know if I want to. I don't know if I want to type there. We could use inequalities instead. So you could say, or I'll just put parentheses here. Or when x is less than -1, and when x is greater than 4. Okay, just another way to say it, and you would be okay. All right. Now it says, what do you notice about the slopes of the curves on these intervals? Well, we talked about it, but we could do better than that. The slope of the curve is positive. Let's bring this all the way over here. Oh no. I got you. All right, be done with that one. No text box right here. All right, it's positive on these intervals. Okay, but another thing you could say at the same time, the graph of f prime of x is positive on those intervals. This is all saying the same stuff. Okay, so all right, so either way you go, you're okay on that. All right, and then starting at the left, state the intervals where the graph falls. Okay, well, we had done that in purple. All right, so it looks like it falls in between those two. So I will say, there we are. The graph of f of x falls or decreases from, I'm going to say on the interval -1 to 4. Or you could say, or when -1 is less than x is less than 4. Okay, saying the same thing. Okay, all right. The slope of the curve is negative on those on that interval. There's just one. Okay? But also at the same time, I want to make note that the graph of f prime of x, the graph to the right, is negative because it represents those slope values. Okay. All right. Now, and we talked about this too. At what values of x on the graph does the function appear to have a max or min? What is the slope of the curve at these points? All right. When we already discussed this, what characteristics of f prime occurs at these points? Okay. So what did we say? That's the -1 and the 4, right? So at -1, about -1, 4, and at about, I don't know, 4, -3, I guess, or so, we have maximums and minimums at the points. So, but it says what value of x. So that's all we're talking about. So I will say when x equals -1 or about, the function has a maximum. Okay. The slope of the curve, I'm doing great, at x equals -1 is 0. Okay. So at that moment, all right, at x equals -1, the graph of f prime of x crosses the x-axis. Okay, or y equals 0. Okay, but it's more than that because it's a maximum. It actually crossed the y-axis from above. All right, but we'll talk more about that later. All right, so then when x equals 4, the function has a minimum. The slope of the curve at x equals 4 is 0. At x equals 4, the graph of f prime of x crosses the x-axis. Again, it crosses from below, and that is what would cause it to have a minimum value on the original function. All right, and again, we'll talk more about that later. But at that moment, y is equal to 0. Boom. Boom. They don't care about punctuation. Oh my gosh. Minimum. There we go. Boom, boom. Fix it. Okay. All right, there we go. It says now, and again, looking at the graph, when I hit the max there, we cross the x-axis. When I hit the minimum there, we also cross the x-axis from a different direction, though. All right, then on D, now look carefully at this one. Why does the graph of f prime reach a minimum value near 1.5? Can you explain what's occurring at 1.5 of the graph to create this minimum on the slope graph? So in other words, why does that happen? All right, and I want that to be discussed by you guys in class. Okay, we need to talk about that in person. You tell me in class. Okay. All right, that's it for now. That's it for example 7.